Hi YouTube, on today's video we're going to be showing you how to test an SCR. Stick around. To test an SCR, I had a few requests on YouTube. If you want to check out my video on IGBTs, you can see that. I'll put a link in the upper right hand corner. Click on that if you want to find out how to test an IGBT. But some of the comments on that video, there were some people asking me to show how to test an SCR. So what I have here is a package SCR with two SCRs inside, and I have two puck SCRs. One of these are bad and two of them are good. So I'm going to go through them and show you what we're looking for. So some of the things you were going to need to do this. You obviously need a meter, and if your meter has the ohm setting, a good meter, and if your meter has the ohm setting, that is what we're looking for. Some test leads or some wire and tape if you don't have test leads like this, and also a AA battery with a 6.8 ohm resistor. This resistor, the tolerance isn't that critical. I have a 6.8 ohm resistor, and as you can see, I made this real rough. I just taped on, I just used some electrical tape and taped on a resistor to the positive side, and I taped on a piece of wire to the negative side. That's all you need. If you do the math, this thing will provide us like 130, 140 milliamps on a good AA battery. What we're looking for in terms of current is we need the current to turn the SCR on. SCRs are current-driven devices. That means we can't apply a voltage to them like some FETs or some transistors, but we have to get current flowing through the gate in order to turn these things on. And the only way we can get current is either with a power supply or a simple battery. Most people are going to have this. That's why I'm showing you this method. A battery with a resistor. Don't forget the resistor, because you need to limit the amount of current you're going to push through these things. So first of all, just a description is I got these puck SCRs here. A good note for you guys is that you guys are trying to check these things, and every one you check, even the ones that are brand new out of the box, seem like they don't work. Well, that's because there is a spec on these that they need to be squeezed. These usually are in DC drive power sections, and they need to have actually pressure on them. There'll be a big heat sink that clamps these things down, and they don't work. Oddly enough, they don't work until they actually have that pressure. So that's a good thing to know. Now, something like this, where it's in a package, you can see this don't need no pressure. It's just these pucks you got to worry about, that you need some force down to actually get the anode and the cathode to touch one another. Another thing to note on these pucks, when you can see there's a big cathode on this side and a big anode on this side. Good way to remember that is that the positive voltage will flow from anode to cathode. The way I always remember it is, because I'm a conventional current guy, positive to negative, and anode is A in the alphabet and cathode is C or K, depending upon who you ask. A to C, A is first, so positive to negative, A to C. I just think alphabetical order. Also, we need that current. Remember that current flow I was just describing before? We need that current to go from this gate to the cathode. So we need positive current flow into here, and it comes out right here. These things are normally driven by some isolation circuit, but when you test them, you don't need that. I'm actually going to set these to the back, and I'm going to do this one first because I don't need that pressure on these. So if I bring this closer to the camera here, you guys can see the pinout. It shows that there's two SCRs inside of there. Silicon controlled rectifier. It's a package because it's usually one side goes to the positive bus, the other side goes to the negative side of the bus, and the middle terminal is fed over to our motor control or to whatever we're driving. So the camera keeps going crazy on me here, but anyways, I'm going to check this one first over here. So that one, we can see that the gate is pin 5 and the cathode is pin 4. So if I come down here, that means I want to push positive current into the gate, which I said was pin 5. So I'm going to come out of this resistor. I said that's a 6.8 ohm resistor. And I'm going to put that on pin 5. And if we look closely on here, pin 5 is this one right here. So I'm going to put that on pin 5. Actually, before I get the current flowing, what I'm going to do is I'm going to have my meter on ohms. I'm going to turn on the light so you can see it better. And the SCR we're actually testing here is the one on the left. And the power, the anode side is 1, and the cathode side is 2. So let's see how good current can flow through this thing. Well, I have open lead, so that's pretty much as high as I can get. I just want to make sure current can't flow through that. I can't get current flow through any of that right there. So it looks like it's off right now. An SCR off won't allow current to pass. In an SCR, a working SCR, I should have described this earlier, it allows current to flow from anode to cathode once it's turned on. And the way to turn it on is you put a current flow from gate to cathode. If the anode to cathode current, I should say, is high enough, it'll keep flowing even if you remove the gate current. But if you got to look in a spec sheet for these because they're all different. Every one of them is different. But just simple checking, we can see right off the bat that I couldn't get any current flow through here with my meter in the ohm section. So what I'm going to actually do is I'm going to get current flowing through this thing by putting this little circuit together here. So now I have current coming out of my 1.5 volt battery through the 7 ohm resistor, going into pin 5, which is my gate, coming out of the cathode and going back to the negative side of my 1.5 volt battery. Now I'm going to put my meter leads back on here, and I can actually see, look at the resistance is in a readable region now. It's high. It's 892 or 0.892 mega ohms or 892 k ohms. It's high, but essentially what I just did was inside of this SCR, I'm starting to turn it on. It has a turn on region, just like any other transistor does. I'm starting to turn it on, and I can see 0.891 ohms when I'm pushing current through there. Now, if I put my meter leads backwards, you're going to see that negative 0.767. You're going to think, how can I possibly have negative resistance? That when you have the gate cathode junction energized or current flowing through it, and this SCR is starting to turn on, all that's saying is that I am actually getting some of the power from this is coming through my meter because I have power on it. But the way I'm supposed to be measuring is this, like right here, 0.891 mega ohms, which means it's starting to turn on. So that SCR, from what I see, the power side of it looks good. I'm going to disconnect this. I'm going to come over to the next one. And the next one on here, you can see that my gate is pin 6 and my cathode is pin 7. So I'm going to put power, or the positive side, on pin 6 and the negative side on pin 7. If I can get it in there, it's a tight fit. Pin 6 and pin 7. And the power on that, the anode was 3 and the cathode was 1. So anode was 3 and cathode was 1. Here again I got 0.896 mega ohms. And if I read this backwards, we're going to get that negative resistance reading, which just means power from the batteries getting into the meter somehow. 0.896 mega ohms. We never actually checked that one in its off state. So I'm going to disconnect that. I'm going to check that one in its off state quickly. Remember, your meter goes anode to cathode. So red, you can see I'm plugged in. The meter is plugged in appropriately also. Anode to cathode. If I check all of my, I can see open lead on everything. If I just go back and forth on everything, everything should be open, because if I'm putting a DC bus right here, I don't want anything getting over to this unless I turn my gate on. So everything should have open lead with this package. So we just tested the power section of that. The next thing we're going to do is we're going to check gate The gate is 5. We're going to check gate to cathode. Let's see if there's a resistance there. And there is. Very low resistance. And some people would think to themselves, well, that's probably bad, but it's not. A lot of these SCRs actually have a built-in bypass resistor for gate to cathode, which is gate to anode open lead. That's good. We're normally going to not see a gate to anode resistance. You don't want to see anything, I mean, unless it's really high. The standard for resistances you want to see, if we check an SCR and I go from here to here, if it said 1 mega ohm, that is probably the limit where I would say that's a good SCR. If it was any less, it would be in the range of bad. If it was more, that would obviously be good, but 1 mega ohms the limit. So everything we checked on here so far is looking good. I'm going to go gate to cathode on this one. 16.4 ohms again. So that's most likely pretty good for us. And I'm going to go gate to anode. You shouldn't have any current flow from gate to anything besides gate to cathode. Gate to cathode should have some resistance, but gate to anything else should not. So in testing this puck SCR right here, what we have, like I said before, is the anode, the bottom side is the cathode, and that little nipple you see on there is the gate right here. That's the gate. So if I start testing this thing, I got my meter set to the ohm setting. If I read a resistance from gate to cathode, if you remember, I said we should see resistance there, but we don't see any here. No resistance gate to cathode. Huh. Well, there should be resistance gate to cathode. Remember I said before? So what I actually do for these SCR pucks, if you remember what I said in the beginning, these things have to have some pressure on them. So I take a vice grips, I taped one side of it so we ain't getting continuity through the vice grips, and I just ever so lightly put the slightest bit of pressure on this thing. Just the slightest bit of pressure, just enough so I can actually give it that little clamping force that I want. So now that I have that clamping force, I'll take my meter and I'll try and read gate to cathode again. Gate to cathode. And now you can see that we have 21 ohms. Good. It's a good reading. Remember, we want ohms from gate to cathode. The reason I check this gate to cathode first before anything else is because I want to make sure I have enough clamping pressure on this SCR. If I don't have enough clamping pressure on this SCR, none of my readings are gonna be accurate because that needs clamping pressure to work. So now that I got that 21 ohms from my gate to cathode, I know the rest of my measurements are actually in tolerance. They're actual real measurements. So first, let's measure anode to cathode, and we can see on here we have 10.4 mega ohms. That's a good reading. It's not shorted. Let's go the other direction. We have 15 mega ohms, 14.5 mega ohms. That's another good reading. It's not shorted. So we'll use this little test circuit I built before. I got a 1.5 volt battery. I'm going to go from the positive side through a 6.8 ohm resistor, and I'm going to go to the gate with this from the negative side of my battery to the cathode. So I got a current flow going out of my battery through the 6.8 ohm resistor into the gate, out the cathode, back to my battery. Now let's measure the resistance from anode to cathode. 1.1 mega ohms. You see how that dropped off? Dropped off quite a bit. 1.1 mega ohms. So what we're doing is we're turning on this SCR right now. If I go the other direction with my leads, there you get that negative resistance again. That's expected because we have this battery hooked up to the circuit. So what we did was we just checked the power section. It's not shorted, and 99% of the time an SCR shorts. 1% of the time something will happen where the gate will be fried and you won't be able to turn on the gate, and in that instance we just checked that. We got a little bit of gate current here, and we can see that the SCR is beginning to turn on. The only thing we really can test with this is the ability for the SCR to latch. In order to do that, we have to have a high current load from anode to cathode. But like I said, that is a very rare failure. It doesn't happen very often. The only thing left to check on this puck SCR is to make sure that the resistance gate to anode is high, and it is 15 mega ohms. But gate to cathode is going to be, like I said, it's going to be a low resistance, and it's supposed to be. Now you shouldn't see 0 ohms here, because then that's shorted. You should have some resistance, and you shouldn't see high ohms. You shouldn't start to see K ohms here. It should definitely be a small reading, like 21. I'd say the top you want to see is 80. You won't want to see over 80. I've never seen over 80. So everything on this SCR looks good. Resistance from gate to cathode. And we have 10.8 ohms. Good. Gate to cathode resistance looks good. Let's check gate to anode resistance. Ooh, 125 k ohms. That's slightly low. That's pretty low. We like I said before, we should see mega ohms here. Let's check just anode to cathode. 120 k ohms. Yep, that's definitely way too low for anode to cathode. Like I said before, this should be 1 mega ohm or more. If you're flirting with the 980k, it possibly is good. It's a questionable SCR. I wouldn't put it back into service if it was that. But some might be designed that way, so it's always good to check your spec sheet. If you have any comments or questions about some of the methods we used today, or some feedback for me in general, or if you have some more videos you want anything electrical or electronics, just leave it down in the comments below. I would really appreciate it if you'd subscribe or hit the bell if you like these videos. Thanks a lot for watching.